point. The bearing is subjected to a radial load of 3 kilonewton and a thrust load of 2 kilonewton. Full point. The machine is to work for 8 hours per day, 8 hours per day for a period of, for a service of 5.5 years. 5.5 years. Based on the strength minimum diameter of spindle is 50 mm, 50 mm. Okay. You note down what are the given data here. So now speed is given here. Okay. So radial load is given, thrust load is given, hours is given, number of years is given, minimum diameter is to be 50 mm. Okay. Now we need to select suitable bearing for these loads. Okay. Now, so first you find out life of bearing required. That is what a bearing life in terms of millions of revolutions. Okay. So let us go for solution. Okay, first we will calculate life of bearing. Okay, so life of bearing required. Okay, so now speed is 1200 rpm. Okay, it works 8 hours per day, so for a period of 5.5 years. Okay, now calculate L required 1200 into 60 into 8 into 365 into 5.5 divided by 10 to the power of 6. So now you find out what is the L required. One 115. You just check it once again. One 156.32 millions of revolutions. Right? Now this is what required. Right? This is what a required life of bearing. Okay. So which has to sustain for 5.5 years and working 8 hours per day, right? Now, once you got the value of millions of revolutions, okay, so next you go on selecting the parameter. Now let us look out. Now they have given minimum diameter of shaft is to be 50 mm based on strength. Right? So that is D equal to 50 mm. Right? Now the thing is that you need to select first initially a 50 mm diameter shaft here. 50 mm diameter shaft. Based on that one, you need to select the parameters. So now you refer design data handbook. Okay. Go for chapter number 16. Okay, and refer table. Now it is of ball bearing here. It is of ball bearing. Okay. Now you have a two series here. Series 62 is there. Series 63 is there. Okay. Series 62 and series 63. Refer page number 387, table number 16.98. Okay. 16.9a. Right. So page number is 387. Page number is 387. Now, as you need to maintain minimum diameter of shaft is to be 50 mm, that is what a small d is to be 50 mm. With related to this one, you note down the value of a C naught and C. The value of C naught and C. Now, basic static capacity. As to the basic static capacity, C naught is how much? For 50 mm. Two zero. Okay. Now dynamic static capacity. 270. Okay. Now you noted C naught and C. This is clear. This is clear how to select the values of C naught and C based on the diameter. Now the thing is that based on these two values, you need to calculate what is the L it can sustain. Okay, L it can sustain. Right. Now what is the first step? So first step is you need to find out FA by C naught. Okay. So step one, you calculate FA divided by C naught. FA is how much? Axial load is 2 kilonewton here, radial load is 3 kilonewton. 2000 divided by how much C naught? C naught is 20595. How much you got? How much? 0.097. Okay. So next, you need to select the value of E based on ratio of FA divided by C naught. Okay. So now select value of E. Now to select the value of E, so you refer table number 16.3 here. Okay? You refer table number 16.3. Okay? So to refer this value of E, go for table number design data and book table number 16.3. Okay? 16.3. Now you have a column 3 here. Column 3 is what? FA divided by C naught. Right? Column 5 FA divided by C naught. Okay. Now how much value you got here? You got 0.97 as the FA divided by C naught. Now which one is the nearest value for FA divided by C naught is 0.084. Right? 0.084. ನಮ್ಮ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬಂದದಲ್ಲಿ 0.097 ಬಂದದ ಸರಿನಾ. So let us select approximate value 0.0. You can go for 0.11. Okay, so 0.11 is nearest value. Okay. So for this one, you can refer the 14th column. Okay. Example for 0.110, E value is E value is 0.30. Right? Correct. Now you go for interpolation method to find out value of E for 0.97. Okay? For 0.97. Okay? So now value of E 0.097 into 0.3 divided by 0.11. How much you got? Zero point. Okay. Now you got a value of E. Okay. You got a value of FA by C naught. What is the next step? You need to find out ratio of FA divided by FR. Okay. Step 2. The ratio of axial load to the radial load. Now axial load is 2 kilonewton, radial load is 3 kilonewton. How much you will get? 0 point. Right? Right. Now check this value with respect to E. Check for E. Okay. Now in this case, the FA divided by FR value is greater than E. Right? So 0.667 is greater than 0.264. Correct? Now, based on this comparison, okay. So now based on this comparison, select value of X and Y. Okay. Select value of X and Y. Okay. Now go back to table number 16.3 again here. Go back to table number 16.3. Okay. Now you refer column number 10, okay, for value of X, okay, and column number 11 or 13 for value of I. Okay. Now as 0.667 is greater than 0.2 something is there, 0.264. Okay. Now the value of Y, sorry, first we'll go for X. The value of X, okay, for 0.667 is greater than 0.264 is 0.56. 0.56. Okay. So right here, assuming, not assuming, you will get only double row bearing here. Okay. When FA divided by VFR is greater than E, you need to go for double row. You need to go for double row. Now V is a factor here. I think what we took yesterday. Think V is a factor. Table number 16.5. What says? Okay, now this is what whether the member is rotating, inner member is rotating or stationary. Okay. So now V equal to what? 1, because inner member is rotating. Right? Now what will get? If you have a relation there, so FA divided by VFR in data and book. Okay. Now you got X equal to 0.56, right? This is what 0.667 is greater than 0.264. You got a value of X here. So by which column you have referred? You have referred to column number 10 here. Column number 10. So next, to find out the value of Y, okay, to find out the value of Y. Now again you compare value of FA divided by VFR with E. Now if you want for comparison, this is what 0.667 is greater than 0.264. Okay. Now how much you got a value of 0. Now in this case, you need to check here. You need to check. Now refer to 13th column here, column number 13. 13th column. Okay. Now in correspondence to value of E, now E equal to 0.0264 you took. Only 2.64 or 0.264? Okay, 0.264 E banta. So you got a value of E equal to how much here? Right? With respect to this one, okay? With respect to this one, you refer column number 13 here. You refer column number 13. Already VFA divided by VFR is greater than E, right? Then you need to refer column number 13. So in column number 13, you have a various values. 2.3 is there, 1.99 is there, 1.71 is there, 1.55 is there, okay? Like that you have a value. Now corresponding to this one, so you just calculate here. Now let us go for E equal to 0.30. You have a value of Y equal to 1.45, okay? So now you go for interpolation method. So now for E equal to 0.264, now what is the value of E? Now this is equal to what? Let us go for Y dash 0.264, okay, into 1.45 divided by 0.3. Now you get the value of Y. How much? Okay. Now you calculate what is the equivalent load here. So refer design data handbook. So notify equation number. So just the equation number equivalent load the. So jana. Equation. So you refer equation number 16.6 here. This is equal to what? XVFR, okay, plus YFA into CS, okay, into CS. Now CS is not specified in data and book, you just add it here, okay. Now write assume here. So assuming service factor or shock factor equal to 1, okay. Now what is the equivalent load we are going to get now here? P equal to X, how much you got? X equal to how much you got value here? X equal to 0.56. Now V is 1, radial load is 3 kilonewton, okay. So value of Y is 1.276. Now axial load is 2 kilonewton. Let us see S equal to 1. Now you calculate what is the equivalent load here. Two, right? Now let us go for life of bearing based on equivalent load. Refer design data handbook. So notify equation number 16.48. Okay? 16.48. Right, what is the equation? Ln equal to, okay, C divided by P to the power of 3. So C you have noted, but it's what a dynamic, basic dynamic capacity, what it is. Okay, so dynamic static capacity. Dynamic static capacity is 27070. C equal to how much? 27070 divided by P, how much you got? 4232. Not to the power of 3 here. Now we calculate ln. How much? Now you just observe here. This is what calculated. So calculated is 261.7 millions of revolutions. Right? But actual required, how much? You just go back. So now required is 1156.32 millions of revolutions. Right? Now write a comment here as the selected value or as a selected bearing not satisfies the required bearing life. Okay, required bearing life, hence need to change dia of shaft or higher graded bearing. That is L calculated is less than L required. So L calculated is 261.7 revolutions. But the what we can say now required is 1156. Required is 1156.32. Okay. You need to repeat the procedure until it satisfies the required life. Okay. Now let us go for higher series bearing here. Now earlier you have selected 62. Now we'll go for 63 series here. Okay. 63 series for diameter of 50 mm. Okay. So value of C and value of C naught. Page number ಎಷ್ಟು ನೋಡ್ರಿ पेज नंबर 388 हो रहे. C0 34720 ಅದ. Column number 7. 34720 ಹೌದಾ? ಸಿ ಎಷ್ಟದ? 47070 ಅದ. Okay. So next we calculate FA by C0. Next repeat step 1 here. Okay. So FA is how much? It is a 2 kilonewton. C0 is 34720. Now calculate how much you are going to get. ಎಷ್ಟು ಬರ್ತಿರೋ? .0. Okay. So next we calculate FR divided by FA. Sorry, FA divided by VFR. I think this is going to remain the same. Right? Now based on this one, check value of E. Now this is what a step 2 this is. Now what is the value of E for 0.057? Refer again table number 16.3. I think 0.057 means you can select 0.056 value. Okay. Now E equal to, sorry, what we can say, this value is approximately how much? 0.056. Right? Now with respect to this one, okay, with respect to this one, what is the value of E? So E equal to 0.057 into, now what is the value of E for 0.056? It's 0.26. Now we calculate value of E. Okay. So now compare this one with FA divided by VFR. Okay. Now in this case, again, this E value is less than 0.667. Right? Again, this E value is less than 0.667. Right? Okay, now I'll just close this sheet. Now I'll share again. Okay. Now how much you got? FA divided by VFR is 0.667. Okay. So E value is 0.67. Okay. Again, this value is more than E value. Okay. More than E value. Now let us find out value of X here. So X is remains the same, 0.56. Okay. Now Y is going to vary here. Okay. Y is going to vary. Now for 0.26, okay, y equal to 1.71. Okay. Now let us calculate it for 0.267. How much you are going to get a value of y? So 1.71 into 0.26 divided by 0.267. How much value got of y? Okay. Now you find out step 3. Okay. Equivalent load. Equivalent load. So P equal to what? X into FR. Okay. Plus XVFR plus Y into FA into CS. Now we substitute. X is 0.56. Okay. V is 1. Radial load is 3 kilonewton. Plus Y is 1.665. Axial load is 2 kilonewton. So CS is 1. So how much we'll get here? Just ಬರ್ತಿರೋ P. Okay. Now we calculate life of bearing. Refer equation number 16.4a. Now ln equal to C by P to the power of 3. Okay. So value of C is 34,000 or 40. How much you got? 47,000. You just check it how much you noted. Value of C. Okay. No, P how much you got now? Just only 5010. Now substitute here. 47070 divided by 5010 to the power of 3. I think now we will get how much? Now in this case also it is not satisfied. Okay. Now you need to change the diameter. Change diameter. Write a comment here. So your ln is less than L required. Okay. So let us take D equal to 55 mm. Okay. D equal to 55 mm. Now for D equal to 55 mm, you note down value of C naught C. Okay. Then you repeat the procedure same. You repeat the procedure same. Right. Then find the value of E. Then compare this value of E again back to this. And find out value of X and value of Y. Then you calculate equivalent load. Substitute back in equation L equal to C by P to the power of 3. Now repeat this same procedure until unless you are going to get L required is less than L calculated. Okay. I hope you got the idea how to find out the life of bearing. based on static as well as dynamic loads.